Welcome to the deep dive. In this session, we're really zeroing in on the Microsoft Intune Service Release 2505. We've got a stack of official docs and briefing notes here.
That's right. And if you're working day in, day out with Intune, managing Windows endpoints especially, this release, 2505, it brought some pretty significant changes.
Yeah, definitely things administrators need to be aware of. So our mission today is basically to cut through the documentation, pull out the critical updates, and, give you the quick version of the essential insights.
Exactly. We're sticking to the technical details from the sources, what's new, what it means for you as an admin on the ground. No fluff, just the facts.
And we've got some, pretty interesting areas to cover. We'll spend a good bit of time on firmware management, DFCI specifically. There's an update there.
And expanded device inventory, too. There's a whole new thing for SIM details on Windows, which is quite neat.
Oh, yeah, that SIM info entity. Plus, some key endpoint security updates across different platforms, and then we'll round off with a few other config and enrollment tweaks.
It really shows how Intune keeps evolving, doesn't it? Pushing deeper into device control, broader platform support. There's definitely stuff here that affects daily work and, future planning.
Okay, let's dive into that first big one then. DFTI, Device Firmware Configuration Interface. Now, it's not brand new, but 2505 added something specific.
Yeah, the headline update from the release notes is support for managing DFCI profiles on NEC devices. So if you're running NEC hardware with Windows 10 or 11, you can now potentially manage their firmware settings via Intune DFCI policies.
Potentially. So not guaranteed for all NEC models.
Right. The source material is clear on that. It's not universal. You absolutely have to check with NEC, your vendor, to see which specific models and firmware versions actually have DFCI enabled. That vendor piece is always crucial with DFCI.
Okay. But maybe stepping back for a second, for anyone who isn't fully immersed in DFCI day to day, what exactly is it we're talking about here?
Good point. So DFCI at its core lets you manage UEFI settings. What most of us still call the BIOS, but after the device has been deployed using Windows Autopilot, and it's enrolled in Intune.
Right. So you're pushing settings down to the actual hardware firmware from the cloud after it's already set up and running. That sounds different.
It is fundamentally different. Think of it like Intune telling Windows, hey, tell the firmware to turn off the USB ports. And Windows uses this DFCI channel to pass that command down to the UEFI. It's remote policy-driven control over hardware settings.
Okay, and why? Why go to that level? What are the big wins here, the capabilities DFCI gives you?
The benefits are pretty compelling, mainly around security and persistence. The first major one is just enhanced security. You're basically locking down the BIOS settings from the end user.
Locking them down how effectively?
Very effectively. The docs really emphasize the resilience here.
Yeah.
Even if a user reinstalls Windows, maybe tries to put an older, less secure version on.
Or Linux or something.
It's exactly. Or even formats the entire hard drive. The DFCI settings you've pushed, they stick. They persist right there in the firmware.
Seriously, so if I use DFCI to disable booting from USB, they wipe the drive, try to boot from a USB stick, it still won't work.
It's precisely the example the source uses. You lock down boot options, maybe prevent booting from external media or older OS versions, and that setting stays enforced no matter what happens to the OS itself.
Wow. That's powerful against attempts to bypass OS controls.
It really is, and it goes further. The source mentions it can help block malware talking to OS processes, even elevated ones, by controlling hardware access below the OS.
Okay.
Plus, it uses public key cryptography to build this trust chain. This is key. It doesn't rely on just the local BIOS password, which can often be weak or bypassed.
Right. Someone could guess it or reset it locally.
Exactly. DFCI blocks local users from changing the managed settings directly in the UEFI menus because of this cryptographic enforcement. Think about disabling the webcam via DFCI. It's off at the firmware layer. It stays off. Doesn't matter what the user tries to do in Windows settings. The hardware itself is disabled by Intune policy.
Okay, that level of cloud-controlled hardware lockdown is definitely compelling, but it sounds complex. I imagine there are some pretty strict requirements to get this working. It's not just for any old machine, right?
You're absolutely right. The prerequisites are critical. You need, obviously, a supported Windows version 10 or 11, and, crucially, supported UEFI firmware.
And that's down to the hardware manufacturer, the OEM.
Entirely. The OEM has to build DFCI support into their firmware. They might ship devices with it enabled, or sometimes it comes via firmware update. You have to work with your vendors, Dell, HP, Lenovo, now NEC, etc., to confirm which specific models support DFCI and what firmware version you need.
So even if an OEM says they support DFCI generally, I still need to verify my specific machine's EU and firmware level.
Absolutely. Always verify.
Yep.
Then the device obviously needs to be managed by Microsoft Intune. But here's the requirement that trips people up, and the sources hammer this point home. It's how the device is registered for Windows Autopilot. For DFCI to function, the device must be registered for Autopilot, either by a Microsoft Cloud Solution provider, a CSP partner, or directly by the OEM themselves.
And this is where that important distinction comes in, isn't it? About manual registration.
Yes, the critical distinction. The documentation explicitly states multiple times you cannot use DFCI if you manually register the device for Autopilot. Like if you grab the hardware hash yourself and upload a CSV file.
But that doesn't work. Why not?
It's by design. DFCI needs what the source calls an external attestation of the device's commercial acquisition. Basically, proof it came through a trusted channel. That trust comes from the OEM or the CSP registering it to Autopilot for you. It builds that secure chain from the factory to your Intune tenant.
Okay, that makes sense. It ties the hardware identity to your tenant through a verified process, prevents someone from just adding a random hash and trying to manage firmware.
Precisely. It's about trust from the supply chain. When a device is registered that way by the OEM or CSP, and the hardware supports DFCI, it automatically enrolls for DFCI management during the Autopilot process. You'll actually see an extra reboot during the out-of-box experience, the OBE. That's the DFCI enrollment step.
Gotcha. So that extra reboot is a sign it's working. The source also mentioned a whole DFCI lifecycle.
Yeah, it briefly outlines the stages. UEFI integration by the OEM, the registration we just talked about. Then creating profiles in Intune, the device enrollment, ongoing management, and eventually retirement and recovery. It's something to think about end to end.
Okay, so let's assume we have the right devices, right firmware, registered correctly by the OEM or CSP. What are the actual steps in Intune to set this up with Autopilot?
The sources lay out basically 4 steps. Step 1, create your Windows Autopilot deployment profile. This is just your standard Autopilot setup, how the device joins, Intra ID, user account type, etc.
Right, the basic Autopilot config.
Correct. Step 2, create an enrollment status page profile, an ESP profile. And the documentation strongly recommends using ESP for DFCI.
Why strongly? What does the ESP do here?
It acts as a gatekeeper. The source says ESP helps ensure the device identity is verified and, critically, that the DFCI enrollment actually happens successfully during Windows setup. By setting the ESP to block device use until all profiles and apps are installed, you make sure the DFCI policy lands before the user gets to the desktop and can potentially mess with things.
Okay. So the ESP holds the process until DFCI is confirmed. Without it, the user might get in before the firmware policy hits.
That's the risk, yeah. ESP is your safeguard for initial provisioning. Step 3. Create the actual DFCI profile in Intune. This is where you pick the specific firmware settings you want to control.
Like disabling the camera or changing boot order.
Exactly. You'll see options for hardware components, radios like Wi-Fi, Bluetooth, NFC, or specific boot settings like allowing USB boot or network boot. You configure exactly what you want locked down or enabled at the firmware level here. This profile is the policy.
Okay, it makes sense.
And the final step, step 4, is just to assign these profiles, the Autopilot profile, the ESP profile, and your new DFCI profile to the right. Microsoft Intra-Security Groups.
User groups or device groups, does it matter?
You can use user groups, but the documentation suggests device groups often make more sense for DFCI. You're applying policy to the hardware itself, right? So like if you have lab machines where cameras must be off, a device group for those machines is cleaner than trying to target users who might use them.
That's a good point. It's policy for the physical box, not the person logging in.
Exactly. And updating settings later is simple. Just edit the DFCI profile, save it, and the changes apply next time the device syncs with Intune or reboots.
Okay. Now, you mentioned an extra reboot earlier. How does the device actually process these settings after assignment during Autopilot?
Right, so there's a sequence. After you assign the profiles and the device starts Autopilot, it hits the ESP. During the ESP phase, there's that first reboot, specifically for the UEFI firmware, to enroll itself with Intune via DFCI.
Okay, that's the enrollment reboot.
Yep. After that, Windows finishes setting up, syncs with Intune, and pulls down the actual DFCI policy settings you configured. But to apply those settings to the firmware, it needs another reboot.
Okay, so reboot 1 is enrollment during ESP. Reboot 2 is after setup to apply the actual configuration to the UEFI.
Exactly. Enrollment first, then configuration application. It's a 2-step dance at the device level. Understanding that helps if you're troubleshooting why a setting hasn't applied yet.
Definitely good to know. What about potential problems? The sources mentioned something about settings clashing.
Yeah, this is a really important configuration detail to avoid issues. In the DFCI profile, you might see settings grouped. For example, a main category setting like radios, Bluetooth, Wi-Fi, NFC, etc., and then specific granular settings underneath like Wi-Fi radio and Bluetooth radio.
Right.
The warning is, if you configure both the main category and a granular setting within it, and they conflict, like you disable the main radios category but enable the specific Wi-Fi radio, the device can get stuck.
Stuck how? Like constantly flipping between compliant and non-compliant.
Precisely that. The source calls it lipping noncompliance. Intune tries to apply the granular setting, making the category non-compliant. NextSync, it sees the category is wrong and tries to fix that, which breaks the granular setting again. Back and forth, never settling.
Oh, that sounds incredibly frustrating. How do you avoid it?
Simple, really.
Yeah.
Don't configure conflicting levels. The recommended way is usually to use the granular settings. Set exactly what you want on or off there and leave the main category setting as not configured.
So be specific at the lowest level.
Generally, yes. Or, if you do use the category setting, make sure all the granular ones underneath are either not configured or set to match the category. The example given is, if you only want Wi-Fi on, leave the main radios category as not configured, set Wi-Fi radio to enable, and explicitly set Bluetooth radio, NFC radio, etc. to disabled. No ambiguity, no conflict.
Got it. Pick a level of control, broad or specific, and stick to it for that group of settings. Don't mix messages. That's a key takeaway.
Absolutely. Now, another really critical area is the device lifecycle. Specifically, what happens when you need to retire a device managed by DFCI?
Okay, yeah, that sounds crucial. How do you properly take a device out of DFCI management?
This is probably the most important procedure in the documentation, because messing this up can leave the BIOS menus locked locally.
Yeah.
Basically, before you wipe the device or delete its Autopilot registration, you must go back into the DFCI profile assigned to that device and change the settings flanked.
Change them to what? You unlock it.
Exactly. You need to set the option. Allow local user to change UEFI BIOS settings to only not configured settings.
Yeah.
And just as important, you need to change all the other settings you previously configured, like disabling radios or boot options back to not configured. You save this updated profile.
Okay, so you effectively unmanage everything and explicitly allow local access via policy.
Right. You let the device sync, get this updated unlock policy, and then you can wipe the OS and delete the Autopilot record in Intune. Deleting the Autopilot record stops it trying to re-enroll later.
That sequence seems absolutely vital. You have to send the unlock command before breaking the management connection. What if someone forgets and just, deletes the device from the assignment group or deletes the Autopilot object first?
The source is very blunt about this. It says deleting the profile or removing the assignment does not remove the settings or unlock the menus. The device just keeps the last policy it received.
So it stays locked down based on the last settings, and now Intune isn't even there to tell it to unlock.
Exactly. You're stuck with whatever the last policy was, and the local user can't change it in the BIOS menus. It's a major potential pitfall.
Wow, okay. That could brick the device for its next life, essentially. Non-negotiable step then. Modify policy, sync, and then wipe and delete. Is there any way back if someone does make that mistake? Any recovery?
There is, but it requires physical access. If the menus are locked because the retirement steps were missed, you have to physically boot into the UEFI menu. Somewhere in there, there should be an option like Refresh Management from Network or Reset Management. Selecting that option will unlock the menus for local access again.
Yeah.
But the source notes, the settings themselves, will still be whatever the last Intune policy set them to. You'll have access, but you'll still need to go in and manually change the settings back to defaults or whatever you want. It recovers access, not necessarily the desired state.
Good to know there's a physical escape hatch, but it sounds way more painful than just doing the policy update correctly beforehand. Really highlights the need for good process documentation.
Totally. Planning for end of life is just as important as deployment with DFCI.
And what about the user? What do they actually see day to day?
Well, mostly they just can't change things in the BIOS. If they happen to go in there, the options you've managed via DFCI will be grayed out or locked. If you've disabled hardware, like the camera.
Yeah.
They might get errors in Windows saying the camera's missing or not working.
Yeah.
The advice is simple. Document it for your users. Let them know if certain hardware is disabled by policy so they're not confused or flooding the help desk.
Makes sense. Manage expectations. So yeah, DFCI, Super powerful for hardware lockdown, but definitely comes with strict prerequisites, careful configuration needs, and those absolutely critical lifecycle steps.
Agreed. It really pushes endpoint management much deeper.
Okay, let's shift gears. Moving from the firmware depths up to broader endpoint visibility. Release 2505 also had updates around device inventory, right?
It did, yeah. A pretty noticeable expansion of what they call the cross-platform device inventory. Intune's now collecting a default set of inventory data for Android, iOS, and macOS devices, not just Windows.
Oh, nice. So more consistent data across the board. How much detail are we talking?
It's getting pretty detailed. The briefing notes mention specific numbers like 74 properties for Apple devices, 32 for Android, collected by default now.
Wow, okay.
This gives you a much more unified view of your whole fleet in Intune. The sources mention key basics collected across platforms: device name, OS version, serial number, manufacturer, model. The core stuff you need for asset management and reporting.
Having that baseline consistently across platforms is huge for mixed environments. Any gaps or platforms not covered by this expanded inventory yet?
Yeah, a couple of callouts in the docs.
Right.
Linux hardware details are currently not supported in this inventory expansion.
Okay, no Linux yet.
And there are some limitations mentioned for specific identifiers, things like serial number, IMEI, MEAD, phone number, ICC, ECE, especially on multi-SIM iOS devices or in certain Android enterprise modes.
Yeah.
So it's a big step forward, but maybe not perfectly 100% uniform on every single data point across every single configuration just yet. Inventory refreshes about every 7 days, by the way.
Good to know. Okay, but sticking with inventory, here's the part that seemed really new and interesting, especially for Windows admins dealing with cellular devices. This SIMinfo entity data collection. What's that all about?
Yeah, this is a brand new thing in 2505 for Windows devices. It's basically adding a whole new section to the inventory focused specifically on the SIM card and cellular connection details.
So SIMinfo just means SIM information. What specific details can Intune pull now?
It's pretty granular. The sources list things like the IMEI and MIDE, those unique hardware IDs for the cellular modem itself.
Okay.
It also collects the ICC-ID, which is the unique serial number printed on the physical SIM or embedded in the eSIM profile. And importantly, it tries to get the phone number associated with that SIM, the actual subscriber carrier like Verizon or AT&T or Vodafone, and the cellular technology it's using, like LTE or 5G. Though it notes the phone number reporting might depend on the SIM device.
That's way more than just knowing if a device has a cellular modem. That's digging into the specifics of the active connection.
Exactly, and it ties in really nicely with Intune's existing capabilities for managing Windows cellular stuff, like deploying eSIM activation codes via CSV.
Right, you could already push eSIM profiles.
Yeah, or configure the SMDP Plus servers for eSIM downloads. Now, with SIMfo inventory, you get the visibility after deployment, or for devices with physical SIMs. You can actually check Intune and see, okay, yep, the correct eSIM profile is active, it's showing the right carrier, here's the ICCD and IMEI.
So what does this mean practically for admins? Why is this SIMinfo data useful?
The briefing doc highlights a few key use cases. First, just better asset management. Tracking those cellular-enabled laptops or tablets using IMEI or ICC-OD is much more precise.
Okay.
You could also help with cost management, maybe reconciling carrier bills if you can see which carrier is active on which device directly in Intune. From a security angle, you could potentially audit if only approved SIMs or carriers are being used.
Interesting.
And definitely for deployment validation. After pushing an eSIM profile, you can quickly check the inventory data to confirm it activated correctly and pulled the right info. It simplifies troubleshooting and verification for those cellular deployments.
That really bridges a gap, doesn't it? Having that cellular connectivity data right alongside the rest of the device info in Intune makes tracking those often mobile assets much easier.
Absolutely. It adds a really valuable layer of inventory data for that growing class of connected devices.
All right, cool. Let's pivot now from inventory over to security. 2505 brought some security enhancements too across different platforms.
It did. One quite notable update is for Endpoint Privilege Management, or EPM. That's part of the Intune Suite add-on, remember.
Right. EPM lets standard users run specific things as admin in a controlled way. What's new there?
They introduced a completely new type of elevation rule: deny.
Deny. Wait, isn't EPM usually about allowing elevation? Deny sounds like the opposite.
It is exactly the opposite.
Yeah.
So while most EPM rules are about defining what can be elevated, a deny rule explicitly blocks a specific file from ever running with elevated privileges.
Huh. Why would you need that? If you don't want something elevated, couldn't you just not create an allow rule for it?
You could, but this is more definitive. It's an extra layer of defense. The source mentions using it to ensure, quote, known and potentially malicious software can't be run in an elevated context.
Ah, okay. So like an explicit block list for elevation. Even if some other mechanism might allow it, the EPM deny rule overrides that.
Precisely. Think about some piece of malware, or maybe just some unwanted utility you definitely don't want running with admin rights. You create a deny rule for its executable. Now, even if a user tries to run as administrator or some other process tries to elevate it, EPM steps in and says, nope, denied. It's a hard block. The source notes it supports most options like other rules, just not defining child processes.
Okay, that makes sense as an explicit security control, a definitive no for specific executables at the elevation point.
Yeah, it adds that important veto power. And staying with EPM briefly, the source is also reiterated some details on configuring file arguments within your allow rules. This gives you finer control.
File arguments, you mean like command line switches?
Exactly. When you set up an EPM allow rule, you can optionally specify which command line arguments are permitted when that file elevated. There's a checkbox, restrict arguments to allow list. If you check that box, the file can only be elevated if it's run with no arguments at all, or if it's run using only the specific arguments you've listed in the rule. If someone tries to run it elevated with any other argument, denied.
Wow, that's incredibly granular. So I could allow, say, a powerful admin tool to be elevated, but only for specific safe commands and block risky ones.
That's exactly the use case. The source gives a great example using DFCI-CMD.
Yeah.
You know, the tool for checking Entra ID join status.
Yeah, familiar with it.
So you could create an EPM rule allowing standard users to elevate DFCI-CMD, but then you enable restrict arguments and add only status and list accounts to the allow list.
Okay.
Now, a user can run DFCI-CMD status elevated, no problem, gets the info they need. But if they try DFCI-CMD, leave to try and unjoin the machine from Entra ID.
EPM blocks the elevation because leave isn't on the list.
Exactly. It lets you grant access to the tool, but restrict how it can be used with privileges. Super powerful for safely delegating specific tasks.
That really is. It's not just the app, but the action. One quick note from the source, though. Arguments are case sensitive, and obviously don't put passwords or secrets in the arguments list.
Good call out. Yeah, definitely don't do that. And remember, EPM rules can be created manually, or you can generate them based on reports of what users are trying to elevate.
Yeah. Okay, moving platforms. What about Android security in 2505?
A big one for corporate-owned Android enterprise devices, so fully managed, dedicated, or corporate with a work profile, is that compliance policies can now detect if the device is rooted.
Ah, finally. That's a fundamental check.
Yeah. If Intune detects rooting, you can have the policy automatically mark the device non-compliant, which can then trigger conditional access to block access or other remediation actions you've set up. Critical security posture check.
Absolutely. Anything else for Android?
A small enhancement for unattended remote help sessions, the Intune add-on for remote support.
Yeah.
For supported dedicated devices, specifically Zebra and Samsung were mentioned, if an admin starts an unattended session where the user isn't there to click Allow, the device screen now gets blocked during the session, and if someone does try to touch the screen while the remote session is active, they get a notification.
Oh, that's smart. So for like a kiosk or shared device being remotely managed, it prevents accidental input or someone shoulder surfing and alerts if they try. Adds security and awareness.
Exactly. Just a nice tightening up of security for those unattended scenarios. Now, shifting over to Linux.
Right. Linux management in Intune is still evolving. What's new there on the security front?
There's a new endpoint security profile specifically for Linux devices managed via the Microsoft Defender for endpoint security settings management scenario.
Okay, wait, that's important. This is not for Linux devices managed by the main Intune agent, but specifically when Defender is acting as the management agent for security settings pushed from Intune.
Correct. That distinction is crucial. This new profile is only for that Defender-driven management path. And the profile itself is called Microsoft Defender Global Exclusions, AV plus EDR.
Global exclusions for both antivirus and EDR on Linux, managed via Intune through Defender.
You got it. It lets you define exclusions that apply across both Defender components on Linux.
How do you define them? Paths, files.
The profile lets you specify exclusions by either file path or by process name. But here's a key limitation highlighted in the source. Wildcards are not supported in this profile.
No wildcards at all. So you need the exact full path or the exact process name. That requires pretty precise configuration.
It does. You have to be specific. And the source also clarifies that exclusions defined in this new profile get added to any exclusions coming from other places, like maybe an existing Defender AV policy. They combine to form a superset of all exclusions.
So it's additive. Okay, and just to reiterate, this is only for Linux managed via the Defender security settings channel, not the standard Intune agent enrollment for Linux.
That's what the documentation clearly states. Understanding your Linux management channel is key to knowing if this profile even applies to your devices.
Got it. Important distinction. All right, we've hit the big ones. DFCI, SIMINFO, EPM deny, Android rooting, Linux exclusions. Were there any other smaller but still noteworthy updates in 2505 from the sources? Yeah, a couple more worth mentioning quickly. First, for AOSP devices, Android open source project.
Right. The more basic Android management.
Intune now lets you use a custom naming template when enrolling those devices. This works for both user-affiliated and userless AOSP devices.
Oh, custom naming. How does that work?
You can create a template using a mix of static text and variables. The source mentioned variables like serial number, device type, and username for user-linked devices. So you could automatically name devices something like AOSP kiosk serial number or user device type.
Super useful for standardization. Much better than generic names for tracking and reporting.
Exactly. Just a nice quality of life improvement for managing those AOSP fleets. The other change was around role-based access control, RBAC, specifically for device enrollment limits.
Enrollment limits controlling how many devices one person can enroll. What changed in RBAC?
The permissions shifted a bit. Roles like the policy and profile manager or folks who just had device configurations permissions, they now only have read-only access to the enrollment limit policies.
So they can see the limits but can't change them anymore.
Correct. To actually create or edit enrollment limit policies now, you specifically need the Intune administrator role.
Ah, okay. So they've centralized control over setting those enrollment caps to a higher privilege level. Good to know if people were relying on those other roles before.
Yeah, definitely a permissions change to be aware of.
All right, well, that seems to cover the key updates from the Intune 2505 service release based on the source material we had.
Yeah, it was quite a packed release, actually. We dug into the DFCI expansion, bringing that deep firmware control to more hardware. We looked at the broadened device inventory, especially that new SIM-FAVL entity for Windows cellular details.
And the security updates the EPM deny rule, adding explicit blocking, the crucial rooted device detection for Android Enterprise, and that new specific Defender exclusion profile for Linux managed via MDE.
Plus the AOSP naming and the RBAC tweak for enrollment limit. Altogether, it's about giving admins more granular control, better visibility across diverse devices, and stronger security tools.
Absolutely. It's more levers to pull, more insight, more ways to lock things down from the firmware up. So as you're listening and thinking about your own environment, what stands out? Does DFCI finally become viable for a specific set of your devices? Could that SIMINFO data simplify how you track cellular assets? Is the EPM deny rule or Android root detection something you can use right away?
And maybe stepping back raises a bigger question, doesn't it? As endpoint management tools like Intune keep digging deeper into firmware, tightly integrating with security agents like Defender, even involving OEM registration, how does that change things organizationally? The traditional lines between the device admin team, the security ops team, maybe even hardware procurement. They seem to be getting blurrier, right? How do skills and responsibilities need to adapt?
That's a great thought to leave folks with. How does this deeper integration impact not just the tech, but the teams and processes managing it? Something to definitely ponder. Thanks for joining us for this deep dive.